Hey guys, this is lesson 18. We have been learning how to divide a one-digit number into a two-digit number, and we've been learning different strategies. So we started off with using place value charts, and then we went into our standard algorithm with just place value, and now we're going to get into the actual standard algorithm. So today's learning target is I can divide using place value and standard algorithm. However, before we do that, let's go ahead and get into our application problem for today. It says Mallory's family is going to buy oranges. The Graham Market sells oranges at 3 pounds for 87 cents. How much does 1 pound of orange cost at the Graham Market? Of oranges cost at the Graham Market. So we know that 3 pounds is equal to 87 cents, but we want to know how much 1 pound is. So that means I have to divide. So I would divide 3 into 87. So I'm going to use my sticks and my stones, or also called the place value, to figure this out. So if I'm dividing by 3, then I need to count by 3. 3, 6. Well, if I go one more, I made too much. So 7, 8. So I have made 2 sticks, and I have 2 discs left over, which means I have to bring them over. Well, 2 tens is equal to 20. So I'm really adding 20 plus 7, which is 27. So now I'm going to count by 3s again until I get to 27. 3, 6, 9, 12, 15, 18, 21, 24, 27. So now it went in evenly. So let's see how many sticks. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I had 9 sticks. That means our quotient is 29. So to answer our question, how much does 1 pound of oranges cost? We would say 1 pound of oranges cost 29 cents. All right. So our whole for our tape diagram would be 87, and we want to divide that. Right now we have 3 pounds of oranges, so this is 1 pound, 2 pounds, 3 pounds. We're trying to figure out how much does 1 pound equal. All right, now let's start off with our actual lesson for today. So remember, with the I do, you want to follow along with me. I'm going to do both place value and standard algorithm. So the first one I'm going to do is place value. So I'm going to put a PV. I know that I'm going to have to make my backwards L or sideways L. Inside of it, I put my whole, which we know is 57. And my divisor, the number I'm dividing by, goes on the outside. So remember, with place value, we want to split these 10s and 1s in half. So now I have a total of 5, but I have to count by 3. So 3. Well, if I go another stick, that means I'm going to get to 6, which is too much. So 3, 4, 5. So I have 2 stones remaining. Remember, we can't have 2 stones remaining, or we can't have a remainder in our tens place. So we have to decompose those. Well, when we decompose, these 2 tens now become 21s, and 20 plus 7 is 27. So now we're going to have to count by 3s again, because we're dividing by 3, to get to our whole of 27. 3, 6, 9, 12, 15, 18, 21, 24, 27. So I have made, and we had no remainders. So I made one stick here. So above my 5, I'm going to put a 1. And then I made 1, 2, 3, 4, 5, 6, 7, 8, 9 sticks here. So above the 7, I'm going to put a 9. Remember that we need to always check our work. So to check our work, we're going to multiply our length times our width. So 19 times 3. I know that 3 times 9 is 27. So I put my 7, and then I add 2 more. 3 times 1 is 3, plus 2 more is 5. And I got 57, which is what I started out with. So I know that this checks out. All right, standard algorithm. So I'm going to put in SA. It takes away all of these sticks, but we're still doing the same process. We're still going to be, in a way, skip counting to figure out how many times 3 can go into 5, and then how many times 3 can go into 7. So I'm going to draw my sideways L again. I have my total in the box, and then I have my 3 on the outside because that's what I'm dividing by. So with standard algorithm comes a few steps. The first step you want to do is to actually divide. So I'm going to write the division symbol up here at the top so that I can keep track. I'm going to divide 3 into 5. So I have to ask myself, okay, well, how many times can 3 groups be made out of 5? Or how many groups of 3 can be made out of 5? Well, I know that 3 can go into 5 only 1 time, because if it goes in 2 times, that would make 6. So above my 5, if I know 3 can only go into 5 1 time, above my 5, I'm going to put a 1. My next step is to multiply. So here's my multiplication symbol. Remember, you always want to multiply your length times your width. So now, if I multiply 3 times 1, that gives me 3. So under the 5, along with the number that I just multiplied, I'm going to write a 3. Now I'm going to subtract because I have to figure out my remainder, right? So I just said that 3 can go into 5 1 time, which is, there's my stick. When I subtract, 5 minus 3 is 2, which matches up with our remainder. So then I have to ask myself, again, I'm going to go back, I'm going to repeat, which means I'm going to go back to the top. Can 3 go into 2? Well, no, it can't. Well, what happened when we found out 3 couldn't go into 2 over here? We had to regroup it. So when we regrouped it, we got 27. Well, look, if I bring down this 7, because I need a bigger number, look what I'm left with, 27, which is the same thing that I got over here. So now I can divide again. Can 3 go into 27? Well, yes, I know that 9 times 3 gives me 27. So above my 7, I'm going to put a 9. So I just divided, I have to multiply. 3 times 9 gives me 27. So I'm going to write 27. Then I subtract. 27 minus 27 is 0. Once you get to 0, you're good to go. You don't have to do anything. So our quotient is 19. And again, we would check our work. 19 times 3. We know that 9 times 3 is 27. So we put our 7, we carry our 2. 3 times 1 is 3, plus 2 more is 5. 57. Okay, standard algorithm, guys, is not a requirement. It's just another strategy. If y'all are getting to where you're not understanding the standard algorithm, that is perfectly okay. You can always come back and do place value. And most of y'all are going to do place value the entire time that you're in 4th grade, and that is okay. Some of y'all will become familiar, become really, really good with place value, and then you'll start to understand standard algorithm. All right, so now let's move to the we do. So I want you to do this one with me. We're going to do place value first. So let's draw our sideways L. Remember that your total goes in the middle, and we're dividing by 5. So with place value, we got to show our 10s and 1s. I'm trying to get to a total of 8, but I'm counting by 5. So 5. Well, if I go another one, I'm going to get to 10, and that's going to be too much. So I have to draw my disc. 5, 6, 7, 8. So now I have 3 discs, and I can't have a remainder of 3. So we're going to have to decompose these. Well, how much is 3 10s equal to? 3 10s is equal to 30. So 30 plus 6 gives you 36. So now I'm going to count by 5 until I get to 36. 5, 10, 15, 20, 25, 30, 35. Oh, if I go one more 5, I'm going to get to too much. So I have to draw my disc. 35, 36. So let's see how many sticks we have. In our tens place, we were able to make 1 stick. In our ones place, we were able to make 1, 2, 3, 4, 5, 6, 7 sticks. But now we have a remainder of 1. So let's check our work. Remember, when you check your work, you want to multiply your length times your width. So 17 times 5. 5 times 7 is 35. Put your 5, add your 3. 5 times 1 is 5, plus 3 more is 8. But don't forget to add your remainder. Plus 1, 85 plus 1 is 86. So we got the same thing we started out with, so I know that our work checks out. Now let's do the standard algorithm. So remember to write your steps. We're going to divide, multiply, subtract. We may have to bring down, so I'm going to put a BD for bring down. And then we will repeat. Okay,